So here's a very tricky question. A piston completes 2,000 revolutions per minute. As the driver accelerates for 25 seconds, the piston is now turning at 4,500 revolutions per minute. Find, to 1 decimal place of accuracy, the angular speed of before and after accelerating, of the piston. Secondly, the angular acceleration of the piston during the acceleration. And thirdly, the total distance traveled by the piston if the driver accelerated for a further 15 seconds, given that the radius of rotation is 5 centimeters. So go ahead and try this problem, and when you're ready, come back for the solution. So here's the first part of the solution where we turn our revolutions per minute into omega, into per seconds. So we do that by multiplying by 2 pi and dividing by 60. So 2 pi gets us the distance traveled instead of a revolution, and dividing by 60 gets us the distance traveled per second instead of per minute. So we get our values for omega, to 1 decimal place of accuracy, as 209.4 for omega naught and 471.2 for omega. The second part of the question asks us for angular acceleration. So we're given, again, omega naught, omega alpha, and t. So omega equals omega naught plus alpha t again. So 471.2 is 209.4 plus 25 alpha. So simplifying everything down, we get alpha is 10.5 per second squared. Now the last part asks us about the total distance traveled by the piston if the radius is should say 15 centimeters, because that's what it's given here. Did a bit of a typo there. So the change in angle is omega naught t plus a half alpha t squared. The change in angle, therefore, is 471.2 by 15 plus a half by 10.5 by 15 squared. So that's 8,249.3 radians. Therefore, the distance traveled, I kind of mixed everything up, this is the wrong radius, as 1237.4 meters. Now, if it was actually 5 centimeters like it was, so if r is 0.05, like it said in the question, the total distance traveled is actually more reasonable at 412.5 meters. So I did indeed make another typo. I know I jinxed it. But if you got 412.5 meters, then you got the correct answer. I just put the wrong number in because I got mistaken with this bit of time.